Welcome you all to another new lesson. This is Unit 14 of your textbook regarding the reflection and refraction of light. So first let's see what is reflection of light. Actually you have learned about the reflection in grade 7, but here you are going to learn more details regarding reflection. So let's see what is the definition for reflection. So reflection is the bouncing back of a light ray into the same medium when it hits on a surface. So here in this simple video it explains what the reflection is. Here the light beam comes and hit the surface and bounce back to the same medium where it comes. In studying reflection, we are using a plane mirror to observe how the reflection occurs. So plane mirror is a flat polished glass surface and it is a reflective surface. So you can easily observe the reflection using a plane mirror. And reflection occurs according to the laws of reflection. So let's see what are the laws of reflection and how the reflection occurs according to these laws of reflection. Okay, before starting the laws of reflection, let's see how to draw a ray diagram to represent the reflection of light through a plane mirror, because you need to draw how the reflection occurs through a plane mirror in your notebook. So you should be able to draw it using a ray diagram. So here in this diagram you can clearly see that there's a light source and it emits a beam of light, and that beam of light hits this plane mirror and reflects or bounce back to the same medium. So let's see how this reflection is drawn in the ray diagram. So here the light ray that comes from the source of light is called as the incident ray, and it hits the surface and bounces back to the same medium. This bouncing ray is called as the reflected ray. So the perpendicular line that is drawn to the plane mirror at the point where the light ray hits the mirror is called as the normal line, and the angle between the incident ray and the normal line is called as angle of incidence, and the angle in between the normal line and the reflected ray is called as the angle of reflection. So this is the ray diagram that you have to draw to represent the reflection that occurs through a plane mirror. Okay, now we will move to the laws of reflection. So here I have attached a simple video copied from the YouTube, and link for the original video is also given here. So we'll see what are the laws of reflection by watching the video. So there are two laws of reflection, and we'll try to study those two laws of reflection by watching this. So this is a very simple activity, and for doing the activity you will need a plane mirror and a laser torch. By using those two instruments you can easily study the laws of reflection. The first, you have to mark the plane mirror by a line on a white paper, and you have to send a laser beam onto the plane mirror. So now you can see that the incident ray and the reflected ray. So you have to mark the incident ray and reflected ray using a pencil, and you can easily draw the ray diagram using those used by joining those marked points. So then you can draw the normal line by drawing a perpendicular to the plane mirror where the light ray hits the plane mirror, And also you can mark the angles of incident and angle of reflection. So you can easily identify that this ray of incident and reflected ray and the normal line. All these three lines are lying on single plane. So in the first law of reflection, it says that all the incident ray, reflecting ray and the normal line drawn at a point of incident are in the same plane. And also when you measure the angle of reflection and the angle of incidence. So here is the angle of incidence. It is 35 degrees and the angle of reflection is also 35. So when you compare the values of the angle of incidence and the angle of reflection, those two values are equal. So in the second law, it says that the value of the angle of incidence is equals to the value of the angle of reflection. So these are the two major laws you find in reflection, and the reflection of light occurs by obeying these two laws. When considering the reflection of light, there are two main types as regular reflection and diffuse reflection according to the surface that the light beam come and hits. So let's see what are they. So in regular reflection, a parallel beam of light comes and hits on a polished flat surface. So the rays of the reflected light beam also remains parallel to each other. So this type of reflection is called as the regular reflection. So regular reflection occurs when the light beam comes and hit to a flat and polished surface. So it is clearly observed through a plane mirror because it has a polished, shiny and flat surface. But when you consider the surface of a wall, here the surface is rough and not polished or a flat surface. So let's see what happened to the reflected light beam when a parallel beam of light comes and hit on such a rough surface. So a parallel beam of light come and hit on the rough surface, and here you can clearly see that the rays of the reflected light beam are not parallel to each other. This type of reflection is called as diffuse reflection. So now you know the reflection of light occurs according to the laws of reflection. So this reason for this diffuse reflection is also the laws of reflection. So in the second law of reflection, you learn that the uh, angle of incidence is equal to the angle of reflection. So by obeying the second law of reflection, it creates a diffuse light beam when the light hits on a rough surface. Now it is clearly explained in this animation. Now let's see what are the differences you find in between the regular reflection and the diffuse reflection. So if you consider the regular reflection, it occurs when the light beam comes and hits on a smooth and shiny surface, and the diffuse reflection occurs when the light comes and hits on a rough surface. And when you consider the light rays of the reflected light beam of a regular reflection, all the light rays are parallel to each other after reflection. And when you consider the light rays of a reflected light beam of a diffuse reflection, the light rays are not parallel to each other and they are in different directions. So these are the differences you find in between the regular reflection and the diffuse reflection. So now let's see what are the day-to-day activities that we are using the phenomenon of reflection. So you know that we all are using plane mirrors to observe the appearance of ourselves. So we are able to observe ourselves through the plane mirrors because of this uh, phenomenon of reflection. And also you may have seen these vivid light patterns that are used to uh, add colors to the stages of shows. So this is also an application of the reflection. And also you can read and read the letters in a book by keeping eye in any direction. So and also you can observe your surrounding very well as a result of diffuse reflection. So these are the instances where some instances that we use the that we make the use of the process of reflection. Now you have learned the laws of reflection, and also you know to draw the ray diagram for the reflection occurs through a plane mirror. So here you are going to draw the image formed by a plane mirror by applying the laws of reflection and the knowledge of drawing ray diagrams. So for that you have to mark the plane mirror first using a straight line, and you have to draw an arrow as the object. So then you have to draw two rays of incident from one end of the arrow to the plane mirror and another two rays of incident to the plane mirror from the other end of the arrow. So here uh, it has drawn the first ray of incident to the plane mirror. So it is perpendicular to the plane mirror. So the angle of incident is perpendicular, or it is 90 degrees. Therefore the angle of reflection is also 90 degrees. So you have to extend the reflected ray into the mirror using dotted lines like this, and then you have to draw the second ray of incident that comes from this same point onto the mirror. So you can draw it using any angle. So this is how you should draw the second incident ray from this arrowhead. Once you draw the ray of incident, you have to mark the normal line. So you have to draw a perpendicular at the point of incident, and after drawing the normal line you should measure the angle of incident and copy that angle of incident as the angle of reflection, because you know that the angle of reflection is equal to the angle of incident. So by drawing the angle of reflection at this normal, you can easily draw the reflected light ray. So after drawing the reflected light ray, you have to extend it until it meets the first reflected light ray. So this is how you have to do it. So you have to draw another two rays of incident from the other end of the arrow you have drawn. So you have to follow the same thing that you have done here to draw the two rays of incident from the other end of the arrow. Okay, now you have to join these 2 points and construct the image. So after drawing this image, you can compare that image with the object you have drawn. So you will be able to see that those two are equal in sizes and the image is a upright one, and also the distance between the object and the plane mirror is equal to that of plane mirror and the image. So here I have listed the features of the image formed by the plane mirror. So it is a virtual image. Virtual means that image cannot be taken onto a screen. So you cannot touch the image or taken it onto a screen when the image is formed by a plane mirror. And also the size of the image is equal to the size of the object. And the distance from the mirror is mirror to the object is always equal to the distance from the mirror to the image. And another main point is that the formed image is laterally inverted. That means the left side and the right side of the image are interchanged. So here in these two diagrams, the lateral inversion is clearly indicated. Now let's see what are the uses of plane mirrors. So we are using plane mirrors in various activities of our day-to-day life. Few of them are, we are using them as looking glasses, and also we use plane mirrors in solar cookers to reflect the light, and also in constructing periscopes, which is used in submarines to observe the upper area. We use the plane mirrors, and also to make the kaleidoscope. Kaleidoscope is a simple toy which is used to produce beautiful patterns, and also it is used in various scientific instruments. And to form the and to produce the multiple images, also we use plane mirrors, and we keep plane mirrors at different angles to produce multiple images. Okay, now let's move to the next part of our lesson, that is about refraction of light. So, the definition for refraction of light is that it is the process of bending of light as it passes from one transparent medium to another transparent medium. So, the path of the moving of light changes when it moving from one transparent medium to another. So this process is called as refraction of light. Now you know what is refraction. So let's identify the phenomenon of refraction by watching this simple video. So here a beam of light enter from one medium to another, and let's see what happened to that beam of light when it enters to another medium. So here a beam of light enter from air to a glass prism. So, if you consider air, there the particles are freely arranged. So, we call that medium as rare medium. And when you consider the glass, there the particles are closely arranged when we compare it with air. So, we call that medium as the denser medium. So, the path of moving of light changes when light enters from rare medium to denser medium, or from denser medium to a rare medium. So here the air is a rare medium and the prism is the denser medium. So when a beam of light moves from the rare medium to a denser medium, it moves or bends towards the normal. And again, when it moves from a denser medium to a rare medium, the beam of light bends away from the normal. So this is the basic phenomenon of reflection. So for example, let's see what happens, or what can we observe when we put a pencil into a glass of water and observe it from the outside. So uh, the light from a light source comes and hit the pencil, and if we consider the area of the pencil, or the portion of the pencil which is exposed to air, uh, the light beams comes and hit that surface and reflected and reach the eye, and no refraction occurs because light travel in the same medium. So the light enters the eye without any refraction. But when you consider this part of the pencil which is found within water, there the light beams come from the source of light and hit the pencil and get reflected, and this reflected light beam subjected to the process of refraction at the surface where the two media get separated. So our eye get a refracted light beam. Therefore, you will be able to observe a virtual image of the real pencil. That's why you observe that it as a bent object. So now let's try to draw a ray diagram for the process of refraction. So here is the ray diagram for the phenomenon of refraction, and the beam of light that comes from the source of light is called as the ray of incident or incident ray, and the refracted light ray, where after entering to another medium, is called as the refracted ray. And the perpendicular line drawn to the surface of separation of two media is called as normal, and the angle in between this normal line and the incident ray is called as angle of incidence, and the angle in between the normal line and the refracted ray is called as angle of refraction. So this is how you are going to draw a ray diagram for refraction. So the thing that you have to keep in your mind is that the beam of light bent towards the normal when it reaches a denser medium, and the beam of light bends away from the normal when it comes to a rare medium. Now let's see what are the applications of refraction. The first one is that the apparent elevation of the bottom of a pond or a container of water. So what do you mean by this apparent elevation? Have you ever observed the bottom of a pond or a container of water, or the bottom of a container of water, by keeping your eye above the level of water? So if you observe the bottom of a container of water or a bottom of a pond by keeping your eye above the level of water, you cannot observe the real depth of that pond or a container of water due to this phenomenon of refraction. So you can clearly observe it by uh, keeping a coin inside a glass of water. So if you observe the position of a coin which is placed inside a glass of water, you will be able to see that it is in somewhat higher position than the original position because of the process of refraction. So this process is called as the apparent elevation. So another wonderful uh, phenomenon of refraction is the dispersion of light by a prism. So when a white beam of light is entered to a prism, it is separated into the seven colors of light as red, orange, yellow, green, blue, indigo, and violet due to the process of refraction. So you will be able to observe a dispersed light beam when a white light beam enters to a prism. So this occurs due to the process of refraction. And also the occurrence of rainbow is a result of this phenomenon of refraction. So now we know that clouds are made up of water droplets. So when uh, there is bright sunlight with a mist or a drizzle, the rainbow can be observed as a result of refraction. So when a white light passes through the water droplets, um, that light beam subjected to the process of refraction, and the light get dispersed into its seven colors. So this light can be observed as the rainbow. So in today's lesson, we learn two main properties of light as reflection and refraction. So if we consider the reflection, it is the process of bouncing back of light ray into the same medium when it hits on a surface, and the light reflects by obeying the laws of reflection, and we discuss about the two laws of reflection, and the regular reflection and diffuse reflection are the two ways of reflection of parallel light when it hits the different surfaces. And also, the other next property of light we learn is the refraction, and it is the change of direction of light when it traveling from one transparent medium to another. And we discussed the natural phenomena associated with those two properties. So now I'm going to wind up my today's lesson, and let's meet with another new lesson in my next video. Goodbye, you all.